Hi, good morning, everybody. Are you hearing me? Okay, lovely. Thanks a lot. Thank you. All right. Yeah. I've been having some. I've been confusing Form 4s and Form 5s in the chat group and sending lots of mixed messages. I send them a sort of um uh details concerning Form 5, and I confuse them. So I don't think I confused the Form 5s yet about anything. So I think we are meeting on the times that we intended to meet. All right. So, okay. So yeah. So good morning again to everybody. We want to deal with this morning. We want to get into the applications of integration, but before that, of course, we want to look at the questions, some of the problems that I hope people had a chance to look at and try, and whatever. All right. Because only if you really look at the problems or attempt them or think about them in a meaningful way by writing down answers, then you are able to get the things correct. All right. And and the main objective of everything, of course, is for you to be able to answer the exam questions, not only in a paper one setting, but also in a paper two setting. Because what you would find happening in a lot of situations is some of you are not trying to prepare for a paper two. That's all. You're just hoping to guess answers or deal with the paper one in the easiest way possible. And the issues you're going to have with that is, should in case, because nothing is set in stone. What if the exam what if they decide to change the exam dates and formats? Because by multiple admission, even to have a paper one on digital platform would probably most likely have to take place in school. And I don't think, it's difficult to see the readiness for this thing even in June. But we are preparing, of course, for the dates, that the official dates, the tentative official dates, right? But in the event, I mean, we have to be prepared. What they could just as likely decide to say, you know what, we are going to revert to paper two, what was originally intended, and then what would happen? Things will all fall apart for us if we are not, covering the work in revision and in practice and whatever, using this idea, right? Using the right idea. So I just like to come back to people and try to implore that, you know what, make sure, have a look at the problems, have a look in a serious way, in a proper way, all right? So that you so that you can be expected to do well when the exam comes around. Because there's only one true way to actually attempt something in ANMATS, if you ask me. It's in long format with details, with full working, and not with just squiggling around. Okay. Okay. So first things first. So let's have a look at the homework problems. And with respect to the homework problems, I don't have an image of the homework problems. Everyone should have the homework problems on their well, I sent it on the chat actually. All right. So I have 12 of you all here. Very nice. 12 of you all. So start by telling me which ones I'm going to go through first, and because on the questions, what I have is basically a number 2 with 6 parts, and then I have a 5, 7, 8, and 9. All right. So where shall I start? I know I'm talking to a blank screen. Are you all?
Can you do K number
Okay, I can't hear you. Could you say that again?
K for the first homework
Um,
on page 4-5, number 2 K.
number 2K.
Yeah.
Okay, I don't know which one is K and number 2. Did I give a number 2 with a K in it? Just could you just tell me the problem? I don't know which problem you're talking about here. Number 2K. Could you just tell me again? What is the question exactly?
They wanted you to integrate cos square of x with the boundary of 5 pi on 12 to 0. 0 to 5 pi and 12. I think I read that. I don't know.
Yeah. Can I send that on the chat? Poison, I'm looking for the question exactly now. So sorry, I know you're just wasting time and looking for this question, but I'm trying to figure out which question is this we're talking about. Number 2K, you said. 2K. I'm not seeing the 2K, but if you can, I don't know if you have a writing tool so you can write the problem here for me, but you were saying anyway, you want to integrate cos squared from? Go ahead. Could you unmute your mic and just tell me?
4-5. It's page 4-5, exercise 17.7. Key.
Oh, okay. So, you're talking about page 4 or 5. Okay. Sorry. So just bear with me. Let me get this thing right. I think we'd have done this yesterday. I don't know if you were around, but no, it's no problem. Let me just grab it quickly. Number 2K. All right, yeah. So 2K says integral of cos squared x. Yes, okay. Integral of cos squared from 0 to 5 pi and 12. Okay, thank you. Integral of cos squared x. Thank you, Serena. From 0 to 5 pi and 12. So this is the first one we're going to deal with. 5 pi and 12. And they want to integrate this. So this is k, all right? It's okay. So what we said yesterday, this function, to integrate the cos squared, what you have to do is use the identity. And we actually went ahead yesterday and proved how we can write cos squared x, or we can write cos squared in this form as a half into 1, well, plus cos 2x. All right. And this came from the double angle formula for cos 2x, right? Because the formula says that cos 2a is 2 cos squared a minus 1. So if I made cos squared the subject of the formula, I'm going to end up with something like that. All right. So this is the idea. We're going to use this substitution for cos squared x in order to do the integration. So what will I have? Let me take this off. So I'm just going to say the integral of cos squared dx would be equal to integral of cos squared. This is equal to the integral from same limit 0 to 5 pi and 12 of a half into 1 plus cos 2x. Cos 2x. All right, dx. And this is equal to you can take the half outside and then integrate 1, which is x. All right, the integral of 1 is x. Then the integral of cos 2x, the integral of cos 2x. So let me put this bracket like this. So x plus 1 over 2 sine 2x. Okay, from 0 to 5 pi and 12. Remember the integral of cos ax plus b, 1 over a sine ax plus b. All right. And what do I have next? Well, this is equal to, we can start substituting. All right, this is equal to a half into, well, x is actually 5 pi on 12. This will be 5 pi on 12 plus a half by sine of 2 by 5 pi on 12 is sine of 10 pi on 12. Remember, for x here, I'm going to plug in 5 pi on 12. And 2 times 5 pi on 12 is 10 pi on 12. What is 10 pi on 12? Well, 10 pi on 12, so this is sine of 10 pi on 12, which is similar to 5 pi on 6. All right. So that's when I plug in the first limit, the upper limit. When I plug in the 0, I'll get basically, let's do it, 0 plus a half sine of 0. And sine of 0 is just 0, but I'm just writing it out in full form. Okay. So that is your substitution. Now, this entire second bracket here will drop to 0 because sine of 0 is 0, okay? So really, we have to work out the value of this first section here, which is going to be a half by 5 pi on 12. So let's just leave that still because we have to take the sine. Half of 5 pi on 12. Pardon my penmanship, I'm just still struggling with this thing. Plus a half. I have to fix this better. Now, guys, what really is the what is sine of 5 pi and 6? I suppose that is what is probably given some of you causing you some headache, boys, because you don't know how to probably get exact values for sine 5 pi on 6. This is why I told you all, the best tool, the easiest tool for you to have, the best tool to have is really the Casio, that if you punch in sine 5 pi on 6, you're going to get a nice answer. But you don't need it, because sine 5 pi on 6, right? This is actually the same as sine of pi, we could say minus pi on 6. Right? Sine of pi minus pi on 6. And what is sine of pi minus pi on 6? Now, we had a set of properties of trigs, if you would recall, and even if you check your summary notes again, in your notes or wherever, or in the textbook, whatever, the properties of trigs, we have exactly what sine of pi minus theta. There's a rule that says sine of pi minus theta is equal to what? Anybody could unmute your mic and tell me.
Sine theta.
Yeah, great, lovely, lovely. So this is actually equal to sine of theta, right? So, of course, you can prove it by going and expanding and using addition formulae. Sine pi cos theta minus cos pi sine theta. Cos of pi is minus 1, minus and minus is a plus. So yes, so this is sine theta. So effectively, what you have, if I'm trying to find the sine of 5 pi on 6, and you have to do it long fashion way, then you're going to say this is equal to the sine of simply pi on 6, because in this case, this acts as theta. So what is sine of pi on 6? Pi on 6 is 30 degrees. Sine of 30 is cos 60. That's a half. All right, that's a half. All right. So what I will tell you all is just to make sure that you plug in a half there from your calculator. Most of you will get a half or whatever, and then we're gonna work this out. So you're gonna get 5 pi on 12 plus a quarter by a half, right? So which is gonna be, let's say, you can pretty much leave your answer like that, 5 pi on 12 plus a quarter. You can leave your answer like this, and there won't be any issues. All right. Or if you want to expand, you're going to get 5 pi on 24 plus 1 over 8. Or you can pull out 1 on 4 or whatever. This is sufficient for your answer for this question. All right. So does this answer your question, boys? Are you happy with this? I think this is a problem. The design 5 pi on 6 is a problem here.
Yes,
That when you start substituting, you had some issues. All right. But what I showed you just now on the other page was how to find sine of 5 pi on 6 in easy way. To find sine 5 pi on 6 using your rules for trigs. But when you're doing integration, really, we're not so much testing how you can find this value. So it is expected that, if you punch in your calculator, you would get your answer. Okay, and nothing is wrong with that. Okay, so the next question, which is the other one?
Good morning, sir. Can you do number 5 from yesterday?
Yes, number 5. So that's number 5 by expanding, right? That's the first part, right?
Yes, sir.
Yeah, great. So let's have a look at that now. So for those of you, I don't have the question up here. I don't have the question up there, but probably maybe I should seek to get a question up here. If you just bear with me a second, let me get the question up here. All right, just bear with me a second. No, that won't be so easy. I'm going to have to email myself the question to get the question here. Sorry, just bear with me. Let me get the question up here. All right. Okay. Yeah, just bear with me, people. Bear with me a second. So. Yeah, this is kind of time wasting. I'm sorry. In the future, I would make sure I have this easily accessible for my Okay, so I'm gonna send it. In fact, I'll just send it on the email as well. I'm getting it's much easier and thing to sometimes send things the other way, which is why